Good way to start the recording. So, all right, let's jump in. Class recording has started, so please don't say anything that you wouldn't want your grandma to hear. Okay? That's my point. All right, yesterday we started talking about a new type of problem where we have an object that is a projectile. It's moving through 2 dimensions. Gravity is affecting it, but unlike the other problems that we've done up until this point, instead of just sort of rolling off the edge of the table, or all of our problems say something like they were moving horizontally, now we have something that's being launched sort of at an angle. And so yesterday, right at the end of the period, we were talking about this situation where the problem gave us some information about this golf ball that this guy was hitting. And it says that the golf ball is hit with a speed of 30 meters per second at an angle of 30 degrees above the horizontal along level ground. And so we drew this purple arrow, and we said that this purple arrow represents the initial velocity of the golf ball. How fast and which way is it going immediately after the person hits it. But, just like it's drawn in the picture, it's not horizontal, it's not vertical, it's somewhere in between. And so at the beginning of this unit, we talked about the idea that a vector that is not horizontal or vertical has components. It's doing 2 things at once. It's moving horizontally at the same time that it's moving vertically. Good? So, here, in the previous section, we did some calculations to basically get the 2 sides of the triangle, and then we calculated the hypotenuse, right? You were supposed to do that in the yesterday for one of the questions, right? Today, I've given you the hypotenuse, and I want you to work the other direction to get the 2 sides. Because if this is the speed that this object is going immediately after the golf club hits it, if we can figure out this side of the triangle, and we can figure out this side of the triangle, that's how fast it will be going horizontally, which is the red arrow, and vertically. The combination of those 2 results in the purple arrow. Okay? Good with that? All right. So for part A of this problem, where it says, what are the initial horizontal and vertical, what are the horizontal and vertical components of the ball's initial velocity? What we're saying is, I want you to take this purple triangle and find the 2 other sides. Find the red side and find the blue side. Okay? So using our trig identities, we can figure out the 2 sides of that triangle because we know one side, we know one angle, and if red is horizontal and blue is vertical, that has to be a right angle. Okay? So, let's work on the horizontal side first. In relation to the angle that we were given, this 30-degree angle that the ball is making with the ground, red would be the adjacent side of that triangle. The purple one is the hypotenuse, so we're going to go cosine to figure out the red side of this triangle. And I'm going to call this side x, and I'm going to call this side y, just for simplification purposes right now. Good? And then we can solve for x here and find out what the horizontal or the red arrow of this triangle is. When you go and plug that into your calculator, make sure your calculator is in make sure your calculator is in degrees, because somebody got messed up this morning with the calculator. So in radians. So go ahead and do this calculation real quick, and let's find out what the red arrow of this triangle is. Can you guys see okay with the gray background? Is that all right? So, you know, turning off the light would help or something like that. All right. We also have to find the blue side here, okay? In relation to the angle that we were given, that 30-degree angle, the blue is the opposite side of the triangle. It gave us the purple hypotenuse. So sine is our relationship between opposite and hypotenuse. So the sine of 30 degrees, right, the angle we were given, is equal to the opposite side, which I have labeled y in this picture, over the hypotenuse, which is 30. You can plug that into your calculator and find the opposite side of that triangle. You should end up with that value. Good with those two calculations? Okay. All right. So what did we just do here? We took an initial velocity. The purple arrow represents the velocity of that golf ball immediately after the golf club. The purple arrow represents the velocity of the golf ball immediately after it was struck by the golf club. It's not horizontal, it's not vertical, so it has components. This horizontal component, the red arrow in this picture, will become, or is, the initial velocity in the x direction. That's how fast this object was moving horizontally right after the golf club hit it. The blue arrow is the initial vertical component. That's how fast it was moving vertically right after the golf ball hit it. Okay? Good with those? You okay with that? In most cases, in this section of this unit, which will be the next week or so, this is going to be the first step that you're going to have to do. I'm going to, in most cases, give you the initial velocity of the golf ball, or whatever object we're launching, but that's not going to be a horizontal velocity, it's not going to be a vertical velocity, that's the resultant of these two. So we need to take the resultant and break it down into its components to find out what was happening horizontally, what was happening vertically. Good for starters? Okay. I'm going to start up a new screen because I run out of space here. We're going to work on problems B and C here, so you guys have more room on your page. All right, so let's take a look here at question B. How long is the ball in the air? Hopefully at this point, if you read a question that says how long is the ball in the air, you can figure out that that question is asking you to solve for time, right? That's part of identifying, or part of doing these problems, identifying what we're looking for. If it says how long is the ball in the air, it's asking for time, right? Okay. Now, I want to draw the next part of this picture because I've seen students get confused about what this picture is telling us in the past. So if you don't draw an accurate picture, or if you don't understand what the picture is telling you, you can end up doing something in the wrong order or in the wrong way. All right. This purple arrow represents the velocity immediately after the golf ball was struck by the golf club. The very instant that the golf club hits the golf ball. But the golf ball will never follow that purple arrow. That's the very immediately after the golf ball or the golf club hits it. But as soon as it leaves the golf club, gravity starts acting on it. Gravity pulls things in that downward direction, right? start accelerating in the downward direction. So even though we draw this arrow right here, originating at the golf ball, if we were to draw the path of the golf ball, it never hits this purple arrow. It looks something like this. Okay? That black line, or the black dashed line, represents the actual path of the ball. The purple arrow represents the velocity only at the very, very beginning. So once we do this, once we do this step and find the two sides of this triangle, basically the purple one's gone. Right? It doesn't affect or it doesn't apply to the rest of the motion. Okay? Now, we have this object moving through the air. It's moving in two directions at the same time. It's moving horizontally and it's moving vertically. This is a projectile motion problem just like the ones that we've done before. Okay? So, we want to know about this spot right here just before the ball hits the ground. Not after it hits the ground, just before. Okay? Two dimensions. If we have two things going on at once, we need two lists. We need a horizontal list, and we need a vertical list. You can write your list wherever you want to. You don't have to write them along the black line there. I'm just kind of running out of room up here. So let's, if you're on your page, start up a part B section, and let's go with two lists. Like we said, part B, how long is the ball in the air? That's asking us to solve for time. Hopefully, we're at the point right now that we recognize time being scalar, right? It doesn't have direction. Therefore, we hopefully know that time horizontal and time vertical has to be the same. So it's asking us to solve for time. We can actually do that in two ways. We could solve it horizontally, or we could solve it vertically, just depending on what information we have to work with. Either way will work because time has to be the same for both of them. Okay? Good with that. All right, now let's start filling in the rest of our lists. If we neglect air resistance, which we can in these problems, this doesn't change. Acceleration in the horizontal direction is equal to 0. That leaves gravity to be the only thing affecting the motion of this object. That means that acceleration in the vertical direction is going to be negative 9.81 meters per second per second. Those two things will always be the same, even though this object has become a projectile moving at an angle. That doesn't matter. Okay? Those two things still apply. All right. The previous section, we broke down this purple velocity into its components. And like we said, purple is the result of a horizontal and a vertical happening at the same time. So our answers from part A become information that we can use for part B. So we just learned that the red arrow on the previous triangle was representing the initial velocity in the horizontal direction. The blue arrow on the previous triangle represents the initial velocity in the vertical direction. That's where these problems become different than the problems we've done previously. We now have an initial horizontal velocity and an initial vertical velocity. Good with that? Okay. Couple things that don't change. If the acceleration horizontally is 0, the initial velocity and the final velocity have to be the same. Yes? But that only applies in the horizontal direction, right? Because there is no acceleration in the horizontal direction. So we can right away make v final in the x direction also equal to 26. That's similar to what we did before. All right, now, here's where things get a little bit trickier, okay? I don't know if you remember or not, but using these three, it looks like we have three known pieces of information over here on the horizontal side. So we should be able to solve a kinematic equation or a UAM equation using these three known pieces of information plus this unknown. But if you remember, I don't know if you remember or not, if you try to use these three known things horizontally and try to solve for time, we run into an issue, okay? This is the equation that has the three known pieces of information and the one unknown piece of information, right? We're trying to solve this equation for time, but the acceleration horizontally is equal to 0, so this whole term just goes away, and we're left with VF equals VI. 26 equals 26, which is true, but it's not what we're looking for, okay? So that leaves us over here on the vertical side. Right now, we only have two pieces of information, but knowing what we learned in a previous unit, we can actually get two more pieces of information. This ball, if we say that we want to find out how long it's in the air, it starts on the ground, or it starts just above ground level, and it ends just above ground level, vertically. If something starts and ends in the same spots, the displacement is equal to 0. So in this case, if we just look at the vertical motion, it goes up in the air, it comes back down, it ends up right back where it started. On the vertical axis, delta y is equal to 0. That works in this problem because it tells us specifically that the ground is level. If there was a hill, or if this golf ball was, if we were hitting the golf ball from up on top of the hill and down into a valley, we couldn't say that delta y was equal to 0. We can say delta y is equal to 0 in this case because it goes up and it comes back down and it ends up right back where it started, at least vertically. Okay? So we have now a third piece of information which we can use to get time. But there's actually one more information, or one more piece of information we can get. When we throw something into the air, gravity slows it down on the way up and speeds it up on the way down. Yes? If we look at the speed, gravity will slow it down as much on the way up as it speeds it up on the way down. When it gets back to the height that we threw it from, or that we tossed it from, or whatever, it's going just as fast, but in the opposite direction, right? If I take this tape roll, I throw it up in the air, I catch it right. If I throw it up and catch it right where I threw it from, it's going just as fast when I catch it as it was when I threw it, just in the other direction. That's true even if we add a horizontal motion. So vertically, the speed just before it gets to the ground, the F vertically, would be equal to negative 15.2. Good with that? You okay with why that has to be that way? All right. Now, we have multiple options about how we can solve for time using our vertical numbers. Pick one of them and solve for the time. Go. Directions are important here, especially because in the vertical direction it slows down on the way up and it speeds up on the way down. If you're ready to make the jump, once you figure out the time vertically, remember that they have to be the same, but time vertically is also equal to time horizontally as well, which is going to be important to help you solve part C. So once you figure out the time in part B, now you can use that time to figure out part C. So go ahead and do that when you're ready. And again, with the numbers that we have over on the horizontal side, there are multiple ways that you can get to figuring out how far does it travel horizontally, which I hope you realize at this point is delta x. Right? There's a couple different ways you can do it. Either one of them should give you the same answer. Good there? Questions? Good? Okay. If you flip it over to the second side of that packet, you'll see some stick figure with a crazy mohawk. So just what? Oh. Make sure you're keeping the two sides separate. Right? I'll come back and check in a second. All right. On the second side, there is a picture of this crazy stick figure guy with a crazy mohawk. I don't know why, but it's the one I found online, so I went with it. In this case here, he's kicking a soccer ball. Question number 3 and question number 4 are exactly the same two problems that we just did with the guy hitting the golf ball. Okay? So let's work on question number 3 and question number 4 to begin with. I will slowly start putting stuff up on the board to see if you guys are doing it correctly. First thing you're going to have to do is you're going to have to take that initial speed with that initial angle, and you're going to have to break it up into its components. Okay? That's the first thing you're going to have to do. So I'll make my way around the room as I'm putting stuff up on the board, see if we're doing things correctly. Feel free to talk to the person next to you. If you need a little bit of guidance, or if you need to bounce something off somebody, I'll be around in just a second. step, you have to break it. First step, you need to break up that initial velocity into its components. I have that up on the board, so if you want to check and see how you did there, make sure that you get in the correct ones. Okay. Notice that I substituted in VIX and VIY as my variables because that's what those two sides of that triangle become. They become the initial velocity in the x direction and the initial velocity in the y direction. Now as we start getting into problem 3 and 4, we're going to make our list and start filling in information that we know. Forgive me for not putting units, I'm just trying to save space. Again, just like we did in the previous problem, because this object lands at the same level that we kicked it from, its displacement on the y-axis is going to be 0, and its final velocity on the y-axis is just going to be exactly opposite of the initial velocity on the y-axis. Remember, though, that only applies when we are landing at the same level that we launched from. Okay? Now you have lots of options for finding the time using your vertical components. Pick one and solve for the time. Once you solve for the time using your vertical components, you automatically know the time horizontally, and then you can just use that time to solve for that horizontal displacement, which is question number 4, right? How far did the player kick the ball? That's going to be delta x, the horizontal displacement on the x-axis. Okay? All right, good there? Get that? All right. Monday, we will work on question number 1 and question number 2. That's a different part in the flight of the object, so we'll pick that up from there. If you didn't watch the videos last night, They are available to you over the weekend. Make sure you watch those videos because they are reinforcing these concepts that we did in class today. Have a good weekend, everybody. I will see you on Monday.